Hey, in this video we're going to look at comparing radians and degrees. So again, when you're first learning about radians, because it's not a unit which you're familiar with, it's often helpful to kind of compare any radian measure you make to the degrees just to get a feel for like what radians are. So sort of the first example which we'll use, which will relate degree and radian measure, is the following. Consider an angle theta, which is one complete revolution. So the angle here, starting at R, goes all the way around the circle one time. So theta is there. So it's one full revolution. So in terms of degrees, we know that one full revolution is 360 degrees. So theta equals 360 degrees. Now in terms of radians, theta by definition is A over R. So R is this, and A is the arc length, which will be the entire circle. Okay, because the angle goes around the whole circle, the arc length is the entire arc of the circle, which is the circumference of the circle. So A equals the entire circumference of the circle. But we have a formula for the circumference of a circle, right? A is equal to the circumference of the circle, which is 2 pi r, right? That's just the formula for circumference of a circle. So we could take this and put it into this equation. So theta is equal to 2 pi r over r. And then simplifying, right, the r's would divide. Theta would be equal to 2 pi, which is, again, we don't necessarily need to write the units, but if we wanted to write the units, that would be radians. Now 2 pi, that's just a number, right? Remember, pi is 3.14159, etc. So that this would be 2 times that. So 2 times 3.14, etc. would be, it's approximately 6.28. So one complete revolution in radians is 2 pi, or about 6.28. Now what you're going to see when we do radians is we try to be exact, so we don't want to have to round this pi value, so we're going to leave it as a multiple of pi. So we say theta is equal to 2 pi if that's one revolution. So these two measurements are the same value of theta, but in different units. So we could, this gives us a way to relate these two units. So we know that 360 degrees, an angle which is 360 degrees, is the same or equal to an angle which is 2 pi radians. So this equation right here is the one we use to kind of relate degrees to radians, although we can simplify this a little bit. Notice both sides of this equation are divisible by 2. So if we divide both sides by 2, then we have 180 degrees, which is half a rotation, is equal to pi radians. So it turns out pi radians, or about 3.14159, is half a revolution. So this equation right here is kind of the equation we use to connect radians to degrees. So I'll show you how you do that in an example here. Say we want to convert a radian measure, or actually let's go the other way. Let's convert degrees to radians. So let's say, here's an example, 1 degree. How many radians is 1 degree? So the way you do this is you just take this equation, 180 degrees equals pi radians, just say rad, RAD. And I want to figure out how much 101 degree is. So what do I have to do to this side of the equation to make it equal to 1 degree? Well, I just divide by 180. So if I divide both sides by 180, I get 1 degree equals pi divided by 180 radians, which you could get as a decimal. It's a very small number, right? That's like 3.14 divided by 180. So it's a very small decimal number. You're going to see when we work in radians, we'll often leave it with the pi in the answer, only because that way it's more accurate. Okay, so actually, this equation is what we use to relate the, or figure out how many degrees we're in, or how many radians we're in a degree. But this equation here is actually the one that's going to kind of help us. It's a little bit easier to work with. So let me give you a second example. Let's say 30 degrees. Let's say I want to know how much is 30 degrees. So what I'm going to do is I'm going to take this equation here. 1 degree equals pi over 180. And what do I have to do to both sides of this equation to make it equal to 30? So to make it equal to 30 degrees, I just need to multiply both sides by 30. So 30 times 1 degree equals 30 times pi over 180. So I'm just multiplying both sides of the equation by 30, which is, of course, allowed if you're dealing with an equation. So 30 degrees equals 30 pi over 180 radians. And then you can just simplify this. 30 over 180 simplifies to 30 pi over 180 simplifies to pi over 6. So 30 degrees is equal to pi by 6 radians. This is actually going to be one you're going to hopefully become very familiar with. It should make sense if you remember your special triangles. 30, you know how important 30-degree angle is. How about 60 degrees? So 60 degrees, remember we have that equation. 1 degree equals pi by 180. Now here, I'm not going to put radians. I did in the previous example. Remember, you don't need to write the units for radians. If it's just a number here, it's assumed to be radians. So 1 degree equals pi by 180. So what do I need to do to both sides of this equation? Multiply them both by 60. So I'll get 60 degrees equals, and now I've got pi over 180 times 60. So I can reduce 60 divided by, or 60 over 180, obviously they're both divisible by 10, and then 6 over 18 would be 1 over 3. And you have the pi, so it would be pi by 3. So 60 degrees is equal to pi by 3. Just as a fourth example, let's go 315 degrees. So it's a bigger one, 315 degrees. And again, you do this the same way. So we know that 1 degree equals pi over 180. Multiply both sides by 315. So on the left side, you're going to have 315 degrees equals pi over 180 over, or times 315. So again, there's some common factors here, and you just have to reduce. This reduces to 7 over 4. So 7 over 4, but there's still a pi there. So 315 degrees is equal to 7 pi divided by 4.